Everybody, and welcome back. Today is going to be all about square root functions. You should find this pretty straightforward. It's going to be dipping back into what we've done with other functions, and you pretty much will know the drill at this point. So we're going to look at the characteristics of square root functions. We're going to identify transformations, and then we're going to write equations from graphs. All things that you have done before. Even without the lesson today, you probably will be able to take a great stab at most of these things. Essential question for today: what are the steps to writing the square root function from a graph? Last lesson we wrote inverse functions from quadratics and cubic equations. The next two lessons are this one and then the following one will talk about those functions that we created, so the square root functions and cube root functions. All right, so square root function, what you'll notice is that it is half of a quadratic function. So a quadratic function having that classic U or N shape. The cube root or square root function has been reflected over the line y equals x, so it's that inverse. And then because we're looking for a function, we're only considering the positive part of the square root, because if we consider the negative and drew it in, we would no longer have a function. Remember, it would not pass the vertical line test. So we are considering just the positive part as opposed to the negative value as well, and that is our square root function. So it has a definite starting point and then it continues on forever in one direction. So in terms of our domain, possible x values, we're going to look at that start point. So in our case, 0, it is included, and then it goes on forever to the right, so to positive infinity. Our range also starts at 0 in this case, and also goes towards positive infinity. So this is the parent function, just square root x. You'll obviously take every function you see and evaluate it for its own characteristics. End behavior, when you're doing a square root function like this, you only have one end behavior. So it doesn't go both directions. It has an initial point. So you would say as x approaches, and in our case, it goes forever in the infinity direction. Y approaches, in our case, it's going up, so it approaches positive infinity. So it's going to continue moving upwards and to the right forever. There is no as x goes to negative infinity, it doesn't approach 0, it actually hits 0, so it's not an end behavior. So it's only going to have a one direction end behavior. All right, so let's just take a look at our general equation. So we've got an a value times the square root. Now you can put a 2 in there or you can leave it out, it doesn't matter. So square root without any number is just a second root. We will start putting a 3 in there for cube root, however. You've got the a value on the outside, you've got 1 over b, so that classic inverse of b, so it's 1 over b for the different transformation, and then h and k normal positions. So in terms of what those letters do, we've got a, b, h, and k all standard, so vertical stretch compression, and then that reflection over the x-axis for a. So if a happens to be negative, there's a reflection. B is that horizontal stretch or compression, and then reflection of the y-axis, and then hk. One thing to note, that initial point, or if it were a completed parabola, it would be the vertex point. That is at h and k, so standard. So if we look at the given function and we had to identify the transformations, we would say, all right, there's a negative a value, so we're going to have a reflection over the x-axis. Remember, it's affecting the y value. So reflection over the x-axis, and then the 3. So now we just consider the negative we took care of, and then we're thinking about, okay, absolute value of this number, it's bigger than 1, so it's going to get larger. So this is a vertical stretch by a factor of 3. H is, so it's x minus 5, which means x minus h, h is 5. So it's going to be a translation right 5. And then k is plus 6, so it's going to be a translation up 6. And that's from the parent function. So we're moving from the parent function, so that's just square root of x. We're reflecting over x-axis, we're stretching it by a factor of 3, we're translating it right 5, and then up 6. And if the question was to graph it, you put in your graphing calculator, you put in Desmos, you can make a table. So you could say, all right, if x was 0, what is f of x, and start graphing, or sorry, value of x, and you start putting in some numbers, seeing what you get. If you put in a number and the f of x value is not possible, so you get like the square root of a negative number. So in our case, say like I put in 4 here for x, or any of these numbers for that matter. If I put in 4, we would get the square root of negative 1, which is an imaginary number. So none of these are actually part of that solution. There's no imaginary solutions. So like 4 wouldn't work. When we get to 5, so then it would be 5 minus 5 is 0, times minus 3 is still 0, so plus 6. So 5, 6 would be that first coordinate. And then we could start putting in some numbers. So square root of 1 is 1, so it would be minus 3. So minus 3 plus 6 is 3. And we would carry on in the same fashion. So you would just start graphing it that way. So we would be at 5, 6, so somewhere up here, 6, 3, so it's coming down. So we're going to see this sort of general curve. All right, so let's just look at one where the b value has something going on. If you get the square root of something x and there's no parentheses in there, what you're going to have to do is factor out whatever that lead coefficient is. It doesn't matter whether it's a decimal, whole number, fraction, like you have to factor that whole thing out from the x and that constant, because it has to be written in the form of 1 over b x minus h. So coefficient of x has to be taken out, and then by default you have to take it out of the h value as well. So if we rewrite this, we would have f of x is equal to the square root of 2 times. So x would be left, factor 2 out of 6, we're left with 3. So if I distributed this, I would get back to 2x plus 6. And then we've got minus 7. So 1 over b is equal to 2. 2 is in that 1 over b position. So to get b on its own, I would multiply by b on both sides. That would cancel over here. So 1 equals 2b. Divide both sides by 2. A half is equal to b. So my b value is a half. So that means there's a horizontal compression by a factor of a half. So let's start listing our transformations. We've got a horizontal. So remember, b is horizontal. It's not greater than 1, it's less than 1, it's a half. So horizontal compression times a half. And then our actual h value is 3. So it's a translation. And then that was a plus 3. So that means for x minus h, h is actually equal to minus 3. So we'll go translation left 3. And minus 7, translation down 7. So just make sure that you are doing that factor out of the b value. I'm probably going to throw a little bit more in the b value slot in this unit, just because the content itself is a little bit easier. So I want us to actually work on that. So figuring out the b value and what effect that has on the graph. All right, take a shot at it. So here are two functions. I want you to tell me what the transformations are. Pause the video, come back, and see how you did. All right, so for the first one, we've got minus a third in the a position. So that means we've got a reflection over the x-axis. We've got a, let's see, a vertical. Now this one is a third, so it's a vertical compression times a third. So it's going to get a third of its height compared to what it was. There's no h value, so h is 0. And then minus 5, so we've got a translation down 5. So you remember, h is 0 if it's not there, because you can add or subtract 0 to x and not change the value of it. All right, number 2, the b value is factored out, which is great, and it's 1 over 4. So 1 over 4 is equal to 1 over b. So b is equal to 4. So we're going to have a horizontal stretch by a factor of 4. X minus h, so h is 5, so we got a translation right 5. And down, or sorry, up 2, not down 2, up 2. So translation right 5, up 2, because that k value is plus 2. All right, next up, writing equations from a graph. And there's going to be two ways to do this. One where we're talking about the A value, one where we're talking about the B. So I'm going to do one of each with you. Key things, our HK value is the initial point. So H is -3, K is -1. And then we do need another coordinate like always. So X and Y. And just like we do in most of these other ones, we're going to substitute in for g of x is our y coordinate. We've got x, we've got h, and we've got k, and we're going to have to solve for a. So -3 is equal to a square root of x is 6 minus h is -3. So I get that double negative situation, and then k is -1. So -3 equals a square root 6 plus 3 is 9 minus 1. I'm going to add that 1 to both sides. So -2 is equal to a times square root of 9, which is 3. And we could have a plus or minus here, but remember we're only accounting for the positives in this case. So a divided by 3 is, or sorry, divide both sides by 3, so we get -2/3 is equal to a. So write your final function, g of x equals -2/3 square root x plus 3 minus 1. And start expecting those a and b values to get a little bit more challenging. I know they've been whole numbers up until now. We're going to start throwing some more fractions in there, particularly with negative numbers as well. All right, so this one, we are looking at the b value as opposed to the a value. So if you get a question and ask you to write it in the form where 1 over b is the value we're looking for, if you solve for a instead, you get the question wrong. It's not what we're asking for. We're asking what is the horizontal stretch or compression in this case. So start with the stuff we want to know, h and k, x and y. So h is 2, k is 0, x is 1, y is 2. So 2 equals square root 1 over b. And we got x is 1, h is 2, so -2 plus 0. All right, so 2 equals square root of 1 over b times -1. Now you might be saying, oh, it's square root of a negative number right now, that you can't do that. Well, not true, because we don't know what b is. So how we get rid of the square root is we square both sides. So remember, opposite of a square is a square root, and vice versa as well. So to get rid of a square root, you square both sides. So 2 squared is 4, and that's 1 over b times -1. So I want to get the b on its own. I'm not really concerned about getting rid of the -1. So I'm going to multiply by b on both sides, and then divide by 4. So I get b is equal to -1/4. So yep, divide by 4, yep, so b is -1/4. So that means when we look at our b value in here, it's going to be 1 over -1/4. And remember, fraction to fraction, the divisor fraction flips, so this is going to be -4. Is going to go in that coefficient of the bracket slot. So that means g of x is equal to square root of -4 times x minus 2, and it's plus 0, so there's no need to put anything else in there. All right, you're going to take a shot at it. So you're going to write the equation or the function in the given format. So notice the first one uses a, the second one uses b. So make sure you are doing it in the correct format. Pause the video, take a shot at it, come back, see how you did. All right, so for the first one, we've got h, k, x, y. So 5 is equal to a square root, x is 4 minus 1, and then plus 4. So I'm going to subtract 4 from both sides. 1 is equal to a square root of 4 minus 1, 3. Did I do all that right? Just double checking my work here to make sure I didn't make a mistake anywhere. Nope, looks okay. All right, so then we've got a, so we've got to get a on its own. So it's going to be 1 over root 3 is equal to a. So 1 over root 3 is a. So we've got g of x equals 1 over root 3. And then we've got x, oh, I don't know why I put a bracket down, square root. And we've got x is going to stay the same, and then minus 1 plus 4. All right, so that one, yeah, look, a little radical going on there. So make sure that you were accounting for that. All right, question 2, writing in for the b value this time instead. So we got h, we got k, we got x, and we got y. So minus 1 is equal to square root 1 over b, x is 8, minus negative 2, so it's plus 2, and then plus k minus 3. All right, so let's add that 3 to both sides first. So we get 2 is equal to square root of 1 over b times 10. So then we're going to square both sides to get rid of that square root. Now, the only time you can square both sides is when you have the square root on its own. So that's why the 3 had to go first. So square both sides, it cancels with that square root. So we get 4 is equal to 10 over b. So if 1 over b times 10 is 10 over b. Multiply by b on both sides, and then divide by 4 on both sides. So we get b is equal to 10 over 4, which is 5 over 2. So that's going to be 1 over 5 over 2, which is going to equal 2/5. All right, so I'm going to write it up here just so we can see it nice and clear. G of x is equal to square root of 2/5 x plus 2, and then minus 3. Okay. So now that you're at the end, what are the steps to writing a square root function from a graph? So you would plug in for x, y, h, and k, solve for the missing a or b value, and just make sure that with the b value, you're remembering that it is 1 over b. So once you solve the b value, you're going to have to just invert that fraction, whatever it is, to fill it into the equation. After this lesson complete, the folder for square root functions, there's an independent practice in there with some textbook work. There's no online option this time. There just wasn't anything on Khan Academy that really fit the bill, and there wasn't anything on Desmos either. So we're going to go with textbook work for this one.